In 1610, a physician in Bologna named Sanctorio Santorio received a letter from a colleague that contained a warning he had not solicited and did not expect. He had been circulating, among the physicians of northern Italy, a description of a new instrument he had developed, a device capable of measuring changes in the temperature of the air and of the human body with a consistency and a precision that no previous medical tool had achieved. The letter told him to stop. Not because the instrument did not work. It worked. The colleague who wrote the letter had tested it and found it accurate. Because a device that claimed to measure the temperature of the air was making a claim that, in the theological framework of the early 17th century, required extremely careful handling. The air was not simply the atmosphere. It was the medium through which God's providence operated on the physical world, the invisible substance that carried divine intention from the heavens to the earth, that bore the quality of seasons and weather as expressions of God's will, that filled the lungs with the breath of life that God had breathed into Adam in the garden. To measure the air was not merely a scientific act. It was a statement about the measurability of divine intention. And the Church, still processing the implications of Galileo's telescope, still managing the institutional consequences of Copernicus, still engaged in the comprehensive project of determining which aspects of the physical world were appropriate subjects of quantitative human investigation, was not prepared, in 1610, to let a thermometer define the terms of that question. Sanctorio did not stop. He published. He measured. He argued. He was not imprisoned, not tried, not condemned by formal ecclesiastical process. He was subjected to something more insidious than formal condemnation. He was ignored. And before this story is over, you will understand how the simple act of assigning a number to temperature, the most ordinary quantitative act in modern medicine, performed billions of times every day by physicians, parents, and patients across the entire world, was, for most of the 17th century, considered in significant parts of Europe to be an act of intellectual presumption, so severe that it bordered on theological offense. And how the resistance to measuring temperature cost, in the specific domain of medicine, more lives than almost any other single failure of knowledge in the history of the profession. To understand why measuring temperature was controversial, you have to understand what temperature meant before it was a number. Temperature, in the pre-thermometric world, was a quality, not a quantity. A quality, one of the four fundamental qualities of Aristotelian natural philosophy, the same framework that organized medieval and early modern understanding of virtually everything in the physical world. Hot, cold, wet, dry. These were the four qualities that, in varying combinations, constituted the nature of all physical substances. They were not measurable in the mathematical sense because they were not conceived as points on a continuum. They were categorical states, present or absent, more or less intense in ways that could be described but not numbered. The physician assessing a patient's temperature in 1600 was not measuring anything. He was making a qualitative judgment. This patient is hot, or feverish, or warm, or cold, using the tool that every physician had used since Hippocrates, his hand. The hand, pressed to the forehead, to the chest, to the abdomen, was the diagnostic instrument. Its judgment was categorical and comparative. The patient was hotter than yesterday, cooler than normal, warmer than another patient with the same complaint, and it was sufficient, within the Galenic medical framework, for the clinical decisions that framework required. Because the Galenic framework was not looking for numbers, it was looking for imbalances, departures from the humoral equilibrium that constituted health, and imbalances were described in terms of which humor was in excess, not in terms of how many degrees the patient's temperature had elevated from a normal baseline. A number would have been meaningless. There was no baseline to measure from. There was no scale against which the number could be interpreted. There was no theory of disease that required quantitative temperature data to function. The thermometer did not fail to find acceptance because it was technically imperfect. It failed to find acceptance because the medicine of 1610 was asking different questions than the ones the thermometer could answer. Galileo made a thermometer. This is one of the most consequential minor footnotes in the history of scientific instrumentation, and it is a footnote because Galileo, characteristically, did not consider the thermometer among his significant achievements. It was, for him, a useful tool for other investigations rather than an invention worthy of dedicated attention. His device, developed around 1593, 2 decades before Sanctorio's letter, was a thermoscope rather than a thermometer. It showed changes in temperature, but did not assign numerical values to them. It consisted of a glass tube with a bulb at the top, inverted over a container of water, in which the water rose or fell in the tube as the air temperature changed. It was sensitive. It showed relative changes clearly. It had no scale, no calibration, no ability to produce a number that could be compared with a number produced by a different instrument in a different location on a different day. It showed that temperature changed. It could not say how much. Sanctorio, who was a close associate of Galileo's and one of the most systematically quantitative thinkers in early 17th century medicine, understood immediately what was needed: a scale. He added graduated markings to the thermoscope tube, fixed reference points against which the position of the water column could be reported as a number, and in doing so invented, in its essential form, the clinical thermometer. He also invented something that had not previously existed in the history of medicine: a baseline. For the first time, a physician could say not merely that a patient was hot, but that the patient's temperature was at a specific, reproducible, communicable point on a defined scale, a point that could be compared with the same measurement taken yesterday, or taken by a different physician in a different city, or taken from a different patient with the same disease. This was not a minor technical improvement on existing diagnostic practice. It was a different kind of knowledge: quantitative, reproducible, comparable, independent of the individual physician's subjective assessment. It was, in embryonic form, the basis of evidence-based medicine. And almost nobody wanted it. The resistance to the thermometer in the 17th century operated on 3 distinct levels that reinforced each other with the same structural thoroughness that appeared in the resistance to the lightning rod, the telescope, and the printing press. The theological level was the most public and the most dramatic. The air, and by extension the temperature of the air, was, in the dominant theological understanding of the early 17th century, an expression of divine providence. Weather was not a meteorological phenomenon with a physical explanation. It was God's communication to humanity, the rain that blessed or withheld blessing, the heat that ripened crops or destroyed them, the cold that punished or tested. To measure the air's temperature was to claim that divine communication was the kind of thing that could be captured on a graduated scale. It was to suggest that God's will could be quantified, that the theological significance of weather could be reduced to a number on a glass tube. This objection was made explicitly, in published theological commentary, by several prominent clergymen in the first decades after Sanctorio's publication. The specific form it took varied. Some objected to the implied reduction of divine agency to mechanical measurement, others to the presumption that human instruments could capture qualities that were by nature spiritual. But the underlying concern was consistent. Numbers were appropriate for the things God had made measurable: the dimensions of the temple, the orbits of the planets as mathematics described them. The qualities of the air were not in that category. The philosophical level was less dramatic, but more practically obstructive. The Aristotelian philosophical tradition that governed university education across Europe in the 17th century had no framework for the kind of quantitative temperature measurement the thermometer proposed. The 4 qualities, hot, cold, wet, dry, were categorical, not continuous. A thermometer that assigned numbers to temperature was implicitly proposing a different ontology of physical qualities, one in which hot and cold were not categories but positions on a continuum, not present or absent, but more or less. This was not a minor philosophical adjustment. It was a foundational revision of the conceptual framework within which natural philosophy operated. University physicians and natural philosophers trained in the Aristotelian tradition were not merely being asked to use a new tool. They were being asked to accept that the conceptual categories within which they understood their entire field were wrong. The professional level was the most durable and the most quietly consequential. The hand was the physician's instrument. The hand pressed to the forehead was not merely a diagnostic tool. It was the expression of a professional relationship, the physical act through which the physician's knowledge and experience and judgment were brought to bear on the patient's condition. A thermometer replaced that act with a number that any literate person could read. A number that did not require years of medical training to interpret. A number that was the same regardless of who held the instrument. The thermometer was not merely a better way to measure temperature. It was a threat to the professional mystique within which the physician's authority resided. If diagnosis could be reduced to reading a number off a glass tube, then the physician's irreplaceable skill, the cultivated sensitivity of the trained hand, the accumulated judgment of years of clinical experience, was not irreplaceable at all. It was redundant. The thermometer that eventually conquered medicine was not Sanctorio's instrument. It was Fahrenheit's. Daniel Gabriel Fahrenheit, a Dutch physicist and instrument maker who worked in Amsterdam in the early 18th century, solved the problem that had limited every previous thermometric device. The problem was the working fluid. Sanctorio's thermoscope used water and air. Both were sensitive to atmospheric pressure as well as temperature. The reading changed not only when the temperature changed, but when the barometric pressure changed, making the readings unreliable and impossible to compare across different locations and different days. Fahrenheit replaced the water with mercury in 1714 and established a fixed, reproducible scale with two defined reference points: the temperature of a mixture of ice, water, and salt at one end, and the temperature of the human body at the other. Then he did something that Sanctorio had not done, and that transformed the thermometer from a scientific curiosity into a practical clinical instrument. He made multiple instruments that agreed with each other. The reproducibility of Fahrenheit's mercury thermometers, the fact that two instruments produced in his workshop gave the same reading in the same conditions, was not a minor technical achievement. It was the property that made the thermometer clinically useful. A single instrument told you the temperature. Two instruments that agreed told you what the temperature was. The distinction is the foundation of measurement as a scientific practice. Anders Celsius produced his competing scale in 1742, the centigrade scale, with water's freezing and boiling points as its reference. And the two scales that now divide the world's temperature measurement between them were both established within 30 years of each other, a century and a half after Sanctorio's first graduated thermoscope. A century and a half. In medicine, that delay was not merely a scientific inconvenience. It was bodies. The specific bodies that the thermometer's delayed adoption cost medicine can be reconstructed, with historical care, from the record of what the thermometer eventually made possible. Fever, elevated body temperature, is the most universal sign of infection, inflammation, and a range of systemic conditions that constitute the majority of acute illness across all human populations. It had been recognized as a clinical sign since antiquity. It had been treated, in the Galenic tradition, as a manifestation of excess heat, a humoral imbalance requiring cooling interventions, bloodletting, cold compresses, dietary restriction. Without the thermometer, fever was a qualitative judgment: hot, very hot, extremely hot. The physician's hand and the physician's eye, assessing color and behavior, and the quality of the patient's distress. With the thermometer, fever became quantitative. Specific temperatures became associated with specific conditions. The temperature curve, the pattern of rise and fall across the days of an illness, became diagnostically significant. The response of temperature to treatment became measurable. The German physician Karl Wunderlich, publishing in 1851, established through systematic measurement of millions of temperature readings in thousands of patients the normal human body temperature, 37 degrees Celsius, and the temperature ranges characteristic of specific diseases. This work, the first comprehensive quantitative description of fever in the history of medicine, was impossible before the thermometer. And it produced, directly, the ability to use temperature as a diagnostic marker in ways that qualitative assessment could not achieve, to distinguish the fever of typhoid from the fever of malaria, to track the resolution of pneumonia, to identify the onset of sepsis before it became clinically overwhelming. The lives that the thermometer saved through these capabilities, through the specific diagnoses it made possible, the specific treatments it enabled, the specific deaths it prevented, cannot be counted with any precision. But they are very large in number. And the century and a half between Sanctorio's first instrument and Fahrenheit's reproducible mercury thermometer, the century and a half during which the theological objection, the philosophical resistance, and the professional defensiveness of medicine kept the thermometer at the margins of clinical practice, represents a century and a half of patients assessed by a physician's hand when they could have been assessed by a graduated scale. The cost of that delay is written in the mortality records of every hospital in the 17th and early 18th centuries. It is not written anywhere that makes it easy to count. The clergyman who wrote to Sanctorio in 1610 was not wrong that the thermometer was making a significant claim. It was. The claim that temperature was measurable, that God's air could be assigned a number, that the qualities of the physical world were quantities waiting for the right instrument, was not a trivial scientific proposition. It was a philosophical revolution. It was the specific revolution that the scientific revolution consisted of, the transformation of qualitative natural philosophy into quantitative science, the replacement of categorical description with numerical measurement, the shift from asking what kind of thing something was to asking how much of it there was. The thermometer did not cause that revolution, but it was one of its most consequential instruments, because the domain it quantified, human body temperature, was the domain that touched every human life at its most vulnerable moments. Every person who has ever had a fever has been assessed by the question, how high? Before the thermometer, that question had no answer. After it, the answer was a number. And the number, it turned out, was the difference between a physician's guess and a physician's knowledge. Between a hand pressed to a forehead and a glass tube in the mouth. Between a qualitative assessment that varied with the assessor and a quantitative measurement that was the same regardless of who held the instrument. The thermometer did not replace the physician. It made the physician's judgment more accurate than the physician's hand alone could achieve. That accuracy, that specific, numerical, reproducible accuracy, is what the clergyman in Bologna feared in 1610. Not because he was wrong that it would change things, because he was right. It changed everything. And the air, God's air, the medium of divine providence, the breath of life breathed into Adam in the garden, turned out to have a temperature. Measurable, reproducible, in degrees, which a physician in Memphis or Mumbai or Manchester can read on a glass tube pressed under a patient's tongue and know, within a tenth of a degree, whether the patient needs treatment. The clergyman's letter asked Sanctorio to stop. Sanctorio did not stop. And every life saved by the knowledge of what a fever's number means is the answer to that letter, written in degrees. In the specific, reproducible, theologically offensive numbers that the thermometer introduced into the most intimate encounter between one human being and the mortality of another. The air had a temperature all along. It was waiting for someone to measure it.